Okay, so the second day, we're going to talk about something in this phrase with respect to y is going to pop up. But before I tell you what that is, I'm going to show you why we need something new. So here's an example one. It says, find the area of the region bounded between these two graphs. And so if I try to do this problem, let's just do this problem like we did the other ones, okay? And so if I draw that approximating rectangle, okay, the top curve appears to be the line. This is where knowing your parent functions works. So it looks like I can do the line, x minus 1. But then what is the bottom curve? Okay, well, even here you may go, oh, I can get y by itself. It's the square root of 3 minus x, except really it's plus minus. Okay, so this bottom curve up until here, this is y equals negative root 3 minus x, and the top curve is y equals positive root 3 minus x. And the line, of course, is y equals x minus 1. So if I want to try to do this, you may go, okay, x minus 1 minus parentheses negative root 3 minus x. And all seems well until you get to the bounds. So you start at x equals negative 1, but where do you stop? Now, this line stops being the top curve right here. Okay, once you get past that, the line is no longer the top curve. So you actually have to stop at x equals 2. And that doesn't give you all the area. It only gives you this much of the area. So what you would have to do is you'd have to add on another integral to take care of this space. Okay, so here the top curve is a root, positive root 3 minus x. The bottom curve is again this negative root 3 minus x. Oops, parenthesis, yeah. Okay, dx. And your bounds would be you'd start at 2 and you'd stop at x equals 3, so 2 to 3. Now, especially if this was a non-calculator problem, like who wants to do this? This is a lot of work. It's possible to do without a calculator, but it is really gross. So I'm going to show you a much easier way to do this problem. So that was kind of just showing you the need for it. So if we think of this not in terms of x, but in terms of y, then here's one thing that we can do. First of all, let's define this line as, instead of y equals, let's define it as x equals. And so if you look at that line, y equals x minus 1, if you got x by itself, it would be y plus 1. So that's what I'm going to call this line now. I'm defining it in terms of y. Okay, this parabola, sideways parabola, is defined just the way it is. So, but again, we got to get x by itself. So if I get x by itself, that ends up being 3 minus y squared. So if you're confused by that, all I did is I took these two things and I got x by itself. Like how normally we get y by itself, I got x by itself. So this time, instead of doing top minus bottom, I'm going to do right minus left. So that whole approximating rectangle I think is really helpful here because we want to find the area of this rectangle. This time, the base of this rectangle is going to be right minus left. You always want to do the bigger or the more positive thing minus the less positive thing. So in terms of y, that would be 3 minus y squared minus y plus 1. Okay, that right there would represent how long the rectangle is this way. Now before we had dx, what do you think we're going to have now? We're going to have dy, and that's the thickness or the height, and it's really small. Remember back to limits and all that stuff? That's what dy represents. Okay, now we're not going the -1 to 4 here. We're kind of going top to bottom. So we have an approximating rectangle here, here, here. I'm kind of separating them so you could see. But all of these rectangles are represented by this expression times dy, length times width, or height, base times height. But we need the y values because this is all in terms of y. Okay, with respect to y could just be said in terms of y. So that means these bounds also have to be the y values. So I'm going to pick the y values, bottom to top, -2 and 1. Just comparing these two things, this is much easier to deal with. I don't even have a square root. I only have one integral. So if this were something you were doing by hand, definitely you would want to do it this way, okay? And so let's go ahead and just practice that in this video, how to do this by hand. You could also, of course, do this in your calculator. You would just use y instead of x. So first thing is, let's clean it up. Okay, so 3 minus y squared minus y minus 1. So I'm going to go ahead and put the negative y squared first. This is more out of habit than anything else. Minus y, and then the minus 1 and the plus 3, that's going to make plus 2. So if I wanted to integrate it now, that really wouldn't be too hard. Just use all those good integration skills that we've been doing. We don't need a plus c because I have bounds. And then you just plug it in. Now it's going to get gross for a second, but not nearly as gross as it would have if I was trying to do it the way I did at the beginning. Now, if you absolutely had to simplify this, you could, whoops, I put in the wrong number there. Did you guys catch that? That should have been a -2, -2. So -2 here, -2. So what I was saying is, if I had to do this by hand, I could. Now, if this is free response, this is a perfect answer. And again, as messy as this is not nearly as messy as the one at the top, which I didn't even finish. Okay, so you could do some fraction work there if you absolutely had to. So this right here I really like because it basically outlines the two lessons, okay? If you have something for vertical rectangles with respect to x, that's what we did day 1. Okay, you're going to do top curve minus bottom curve, you'll have the dx, you'll have the x values. But for some problems, it's easier to do it this way with respect to y. We're going to practice this a little bit more today, day 2. Right minus left, and you have the y values there. So everything's in terms of y. Okay, so let's look at this next one. We got a graphic. They don't give us a graph here. So just start by drawing your x and your y axis. Let's start with the one you probably know how to do, which is the vertical line. Hopefully you do. Okay, so this is x equals -3. Vertical line. Now, if you're not really sure how to graph this using conic sections or anything from last year, then just make a table. Like, just think, if y is 0, then what would x be? Okay, like literally just make a table. Instead of, though, coming up with x's, you would come up with y's. So if y is 0, x is 1. So I'd plot that point. All right, if y is 1, 1 minus 1 squared, that would be 0. So 0, 1 is a point. Now also, if y is -1, x would still be 0. And so this is not a function, that's okay. And then you could just keep going. If y is 2, 2 squared is 4, 1 minus 4 is -3. So we would plot the point 1, 2, 3. +2, and there's going to be another point down here. And so it's a parabola. If you think about it sideways, it's really a parabola that's reflected left and shifted to the right one. However you do it, you got to do it. Okay, so back to the problem at hand. We could do this one with respect to y, but what I'd have to do here is solve for y, get y by itself, and it would be messy. So I'm going to go ahead and do this one in terms of y, which means we have this horizontal rectangle. So what is the area of that rectangle? It's going to be the right curve. And remember, they have to be in terms of y. So x equals this, x equals that. It's okay that this is -3 and not a y. It's just they have to be basically x equals. So the right curve is 1 minus y squared. The left curve is a line, but it's still there. It's -3. So right minus left. Okay, that's this length. The height of that is going to be dy, change in y. So you multiply it, all of that, by dy. Add up all the rectangles. That's what the integration symbol does. You've got to say, okay, what's my y value down here? So not -3, that's your x. Your y is -2, and your top y is 2. This right here is going to be the hardest part to get initially. So again, you could do this by hand. You could do it in the calculator. If you wanted to do it in the calculator, what you would need to do is you'd need to go to the calculus menu. You go integrate. So 1 minus y squared. And you can type in minus -3, or seriously, you can just type in 3. Okay, comma, y, comma, -2, comma, 2. Okay, and you get 32 over 3. This answer may look familiar because it's what we had on example 2, the previous lesson. Okay, if you wanted a decimal, just do diamond enter. Okay, let's look at just a couple more examples in this video. All right, hopefully you remember from even geometry that this makes a circle with radius 5. So without doing any crazy stuff, the area of a circle is pi r squared. And so we'd have pi times r squared, which would be 25 pi. And that as a decimal is going to be 78.54, something like that. Okay, so I already know the answer, but we need to practice this a little bit more. So here's what we need to do. We need to either do this with respect to x or with respect to y. Since today was new with respect to y, let's get x by itself. So the first thing you would want to do is subtract over y squared. So we could do this either way. I'm just choosing to do it this way. So x would be the square root of 25 minus y squared, and x would be the negative square root. This would basically be the right and left semicircles. Okay, so if I were graphing this, so there's 5, there's 5, there's 5, there's 5. Here's x-axis, here's y-axis. So all of these are 5s. You would have the left semicircle would be this one right here, negative root. The right semicircle would be the other piece. So we could have done top and bottom. I just chose this. All right, so if I'm doing it this way, then I got to have these rectangles go sideways like that. So I would go right curve, which is the positive square root, minus the left curve, which is the negative square root. Okay. That represents the width of that rectangle. The height of the rectangle is dy. It's the thickness. It's the change in y. And if I wanted to find area of this whole shape, I would add them all up. Now I already know what the answer is. We'll check that in a minute. So what are my y values from bottom to top? -5 to 5. So if I had chosen to do this, so this is with respect to y, WRT with respect to y. If I'd chosen to do this, though, with respect to x, it would be almost identical because circles are very symmetrical. And so if you note it, you could simplify this a little bit, but let's just go ahead and do this one in the calculator because I feel like we actually need more practice with this than with by hand. So I got 25 minus y squared. Got to close those parentheses, minus negative square root of 25 minus y squared. Okay, close the parentheses on the square root, close the parentheses on the minus part, comma y, comma -5, comma 5. And if you want an exact answer, just press enter, and it should give us 25 pi. That's what we got. If we want an approximate decimal answer, We already know this is going to give us that 78 number. Okay? So same exact answer. So you may ask, well, why on earth would we do it this way? You wouldn't. If this was all you were doing, you would want to do it the easy way. But I wanted to practice, and there's something that we're going to do after spring break that this really applies to. And so this was a good thing to kind of go through now. All right, let's do one more example. Okay. And when you're looking at a problem, you may not know, hey, should I do this with respect to X or with respect to Y? So I'm not going to tell you yet which one is easier here. You might pick up on a clue, but let's just go ahead and graph this and kind of play this out. Okay, so this y squared equals x. Again, if you're not sure how to do that, just go through and make a little table. Okay, since the y is the squared part, I'm going to go ahead and do that first. So 0 squared is 0. 1 squared is 1. Okay, but if I type in a -1 in for y, I would get a +1 for x, so 1, -1. So this is looking like a parabola opening to the right, and it is. If I plug 2 in, I get 4 for x, so then I plot the point 42. The hope is that you do this enough that this kind of becomes like secondhand. You want your graph to be as accurate as you can make it. Now, this may not be accurate enough. Hint, hint, it's not, but I did this on purpose. You won't necessarily know if you needed to keep plotting points. But once I plot this, I need to know where they intersect. So if I started with a y-intercept of -1.5, that would be kind of hard. So I'm going to do a table for this one as well. So even though this is a line and I know how to graph lines, I'm going to start with a table and not with 0. But with 1, because if I plug in a 1 here, 1/2 times 1 minus 3/2, that's going to give me -1. So this graph over here, it has a point right here, and I love that because that's an intersection point. Now you could keep plotting points if you wanted, or this would be a good time to go ahead and use slope, up 1/2. And what you want is you want to see where this intersects, so up 1/2, and I don't see that yet. So I'm kind of playing dumb just a little bit. All right, I need to see this intersect. So that means that I didn't graph enough. So I kind of did that on purpose so that it's okay if you have to erase and go back. All right, let's just go ahead and go up 1/2. And that's not going to intersect me either. Okay, you're going to have to go all the way out. So I should have plotted another point here, 3. 3 squared is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and that's going to be 3. So that's that. Let's see if this is a point on the line, up 1/2. It is. So this was just kind of like a quick review in graphing. All right, now, if I tried to do the whole vertical rectangle thing, I want you to notice it would be different over here as it is over here. Like the top curve would be the same, but the bottom curve would change. This is your big indicator that you don't really want to do it that way. You could force that, but it would just be more work. So what would be a lot easier is to go ahead and just accept the fact that this was with respect to y. There's your big indicator right there. The right curve, you have to get x by itself here, okay? And over here, this is already an x by itself. So if you're going to do this, you have to do that. But it's not too bad. Like, for instance, the first thing I would do is multiply everything by 2. So 2 times y, 1/2 times 2, that cancels. 1/2 times -3/2, that's just -3. So you end up getting x equals, add the 3 over, so 2y plus 3. So in this video, I'm kind of going through just some things you already know how to do, but it really trips students up, so I wanted to review it. So our integration is going to be the right curve, which is this line. Again, I'm doing this with respect to y, or in terms of y, minus the left. Okay, that right there tells me how long the rectangle is sideways. The height would be dy, so I want you to notice y, y, y. I ask myself that every day. Just kidding. The last thing I already told you at the beginning of the lesson, this is where students get mixed up. These have to be y values. So look at your intersection points and find those y values. This one's going to be -1. This one up here is going to be 3. Okay, one quick thing, since this is my video and I can do this. If you needed help with the graphing, so far I haven't used the calculator on this, but if this was a calculator problem, you could find those intersection points a different way by solving and setting the two things equal to each other. So y squared equals 2y plus 3. So it's just a resource, not a crutch. Don't forget the comma y. That's what you're solving for. And it's going to give you 2 answers, and that's good. You want 2 answers. Okay? So this is just a resource to help you with that stuff. Okay, and of course you could do this part in your calculator. I've already done that a couple times, so I'm going to go ahead and just give the answer here. 32 thirds, 10 thirds, 9 halves. There's a few answers that just pop up an awful lot, so don't get freaked out if you see that. Okay, so you have a book assignment, and this has to do with day 2. It's only 2 problems, and the answer's in the back of the book. So that's it. Oops, wrong button.